Hello, everybody, and welcome to 90 Days of DevOps, the 2024 edition. My name's Jeff Burke, and I'm going to be doing a presentation today about Kubernetes API security. With my presentation, I'll also do a demo, and I'll be leveraging open-appsec's Playground for their web application firewall. Okay, so what I want to talk about today are basically two aspects of Kubernetes security, API security, that is. The first one is in relation to the Kube API server. I'll go over that briefly because, of course, it's very important, but also because it's been talked about quite a bit and there's a lot of information about it. I think that's been well covered. However, web application security or APIs inside your Kubernetes cluster that are being exposed by your applications. This is something that I think perhaps does need a bit more attention because of the fact that it makes all your applications potentially vulnerable. Okay, so with that, I will switch to my presentation. So again, I am Jeff Burke. I'm a certified Kubernetes administrator and a certified Kubernetes application developer. And until recently, I was a certified Kubernetes security specialist, but I let that expire because I didn't want to spend $395 right away, at least, to redo the exam. It's only about 2 years. I'm an open-appsec ambassador, and my full-time job is community manager at Object First. So 90 Days of DevOps, an introduction to API security in Kubernetes. So this is an introduction. Basically, if you're brand new to this, hopefully you'll learn something and will apply some of these lessons. All right, so when it comes to Kubernetes API server security, what are we talking about? Well, first and foremost, we're talking about transport security. Now, if you do an installation leveraging kubeadm, this is all done for you. You know, the certificates, you see that all coming up in the TLS and whatnot. However, if you really want to understand what's happening, you could build your own Kubernetes using Kubernetes the hard way. Kesley Hightower does that. There's a few other ones out there you can use. And that'll show you how you can build these individual components, how everything has certificates, and all communication should be encrypted among components in your server. Now, the next and extremely important step for your Kubernetes API server security is authentication. Okay, when I mean authentication, I mean getting let into the cluster to do things. Now remember that Kubernetes does not have users per se. I mean, there's certificates, whatnot, but generally you want to leverage a third-party application to allow you authentication. So something using OpenID Connect, something of that nature. Some distributions like OpenShift have this built in. All right. Now, as opposed to authentication, there is authorization. Think of authentication as being let into the house, front door. Authorization is where you can go in the house. What rooms can you open? So what can you do inside the cluster? And generally speaking, this is where you want to bring in RBAC, role-based access control. So here you can differentiate between different users, who gets what, who gets to do what, and also applications. RBAC is leveraged now universally. It is a must. etcd security, so very important, especially if you're using vanilla Kubernetes or any Kubernetes that's using the etcd database, you must protect that. You can go as far as encrypting the etcd database if you like, but at the end of the day, you've got to make certain that an attacker cannot get direct access and be able to manipulate that, because then they can create resources, they can do all sorts of things in the etcd database, delete things and whatnot. So that's equally as important when it comes to your Kubernetes cluster. Now, another thing too, which is pretty much common sense, but you'd be surprised, stay relatively up to date. Oh, and I left out the date. So stay relatively up to something. I left that out in my PowerPoint presentation. But what I'm trying to say here is stay up to date, relatively speaking. You don't want to be on the latest release, obviously, especially if there are a lot of changes, but you also don't want to be way behind because there are a lot of fixes and improvements. So pretty straightforward. By the way, at the end of my presentation, there is a list of the sources that I have. These are all excellent articles which go much deeper into all of these subjects. Okay, but what I really want to focus on today is Kubernetes application security, okay? And when I mean application security, well, I'm talking about leveraging a web application firewall. So specifically to protect your applications, okay? And why would we need that? Well, most obvious reason is protect us from vulnerabilities, okay? There are a lot of vulnerabilities out there, and you simply don't rely on updating your application, because by the time the application is updated and there's an update available, who knows what could have happened. And let's face it, these exploits come out very quickly. And so even if developers are working on their applications and are keeping things up to date and fixing bugs quickly, can you risk that time frame in the sense that by the time the exploit's out and the fix is made? Perhaps not. Okay, compliance and data security. Well, compliance, because of all these break-ins and all these things that are happening, companies are now following all sorts of compliance rules. There are even compliance officers. I've dealt with them. And anything you can do to prove that you've gone the extra mile or the necessary mile, depending on how seriously you take these threats, adding a WAF will help. Monitoring and logging, obviously a web application firewall will provide you with extra logs and extra capability to monitor. Now, the fourth point here, which is excellent, is harnessing machine learning for adaptive security. Now, why is this so important? Well, when I mentioned before, when I was talking about vulnerabilities, very often vulnerabilities are discovered, most often in secret, and exploits are created extremely quickly. And there is that time gap between fixes and when the exploit appeared. A WAF, which harnesses this machine learning adaptive security, can detect patterns and can learn and can basically protect you before a fix is out there. So it's very important. Yes, there can be false positives, but really compared to the amount of times it can save you, it's worth implementing. Okay, managing real-time communications. Okay, if you have multiple clusters, all sorts of communication taking place, you'd want to be able to manage that too, and WFs can perform that task as well. API security and native Kubernetes integration. Well, I do a lot of disaster recovery, and one of the themes that I talk about constantly is you want to use Kubernetes native applications, integration, things of that nature. Because obviously, applications can be anywhere. They can be on a Linux VM, they can be anywhere. But you don't want to leverage applications or solutions which are designed for something other than Kubernetes. Stick close to the native integration. And when I say that, one of the things that you take example would be, for instance, which WAF to use. I'm going to talk about open-appsec today, but if you're, for instance, leveraging EKS or AKS, it's probably better to go with the native web application firewall that's provided by AWS or Microsoft, okay? So native integration also, I think you can stretch that to, use what's best in the environment or what environment you're using. Okay, and integration with CI/CD pipelines. That goes without saying. This is an automated process. You certainly want something to protect you from anything getting into your automated processes. All right, so what vulnerabilities are out there and what techniques are used? Just name a few. Well, there's Log4Shell, which hit last year at Christmas. Very disruptive. Spring4Shell, a similar one. Again, these allowed you to run arbitrary code. As for techniques, SQL injection, we're actually going to look at that today. We're actually going to perform a SQL injection, believe it or not. It's going to be a lot of fun. Cross-site scripting, cross-site request forgery, session fixation. Now, I'm not even going to pretend to understand or claim that I understand what these are. I know they're bad, and that's all I need to know at my operational level. But what I do know is that there's a whole myriad of these type of techniques out there, and I need something to protect my applications from them. Okay, so I've got a whole bunch of sources here. These are excellent articles. I recommend that you read them. They go a lot more into deeper detail, which I've on the subjects I just kind of briefly gone over. So definitely go and read them, and you will get a much deeper understanding of this. All right. So what I'm going to do now is a demo. And the demo I'm going to do is from open-appsec. They have a playground on their website where you can perform these same steps, and it'll show you basically how a web application firewall protects your API. So anyone can go there. I don't think you even need to log in. You can log in if you want, if you create a login, to see and do what I'm going to do right now. Okay, so let's head on over there and we will see the playground. Okay, there it is. Now there's a bunch of them here. There's Kubernetes, and that's what we're going to focus on. But also there's a Linux Nginx playground, Kubernetes Kong playground if you use that, and a Linux Kong playground. So I don't actually use that, and a Kubernetes CrowdSec playground. But let's just keep to the stick to the Nginx ingress playground because that's the one I know better. And we will fire this up. Again, what are we going to do? We're going to do a SQL injection, and the goal of it is to be able to access confidential, classified information. Okay, so this is like a real world scenario. It's nothing crazy. It's nothing that's been thought up. And here's a nice little diagram they have here showing the ingress, going to service, and the pods behind it. Okay, our application will be called Acme Audit. Okay, it's a demo web application with multiple security vulnerabilities. How wonderful. Okay, so, and we're going to, as I said before, perform a SQL injection in order to gain access to the confidential information. Okay, so we'll wait for this to fire up, and then we will check and see what is in here. It comes up relatively quickly. I'll just copy this command in. I'm too lazy to type. And we'll see what we have. Well, we have a cluster, and as you can see, there is our web app namespace with our Acme Audit application, which has all of our wonderful vulnerabilities. Okay, so here they propose us to go into the web browser, which we will do. And it'll bring up the login, I imagine. Yes, there's the login. And this is basically what we need for the SQL injection. Now, again, I am not a coder, hacker, cracker, so I don't understand really what this is doing, but I know it's bad, and I know it'll be successful. So basically, you copy into the user login box this string, and we will do that. Let's copy that in there. And it said there in the instructions you can put in any password you want. So I'll just type a bunch of googly gook, and let's see what happens. Okay, let's wait. Hopefully we'll break in. And, well, it wants me to save that. I'm not going to. Look at this. Acme Audit, important information. This system is strictly restricted to auditors and finance department. Well, no longer. And what do we have here? So total revenues, income, blah, blah, blah. Oh, millions of dollars. Well, I like seeing that. I certainly have never seen that on any of my income statements. So it's nice to see on someone else's. So this is basically showing us that we've gotten access to this top secret information. And now we can go and, oh, look, Exxon Mobil. Oh, it's an oil company on top of everything else. We can go and do all sorts of bad things. So we don't like this, and this is not good. And this is a real vulnerability. It's in this application, obviously in the database, and it has allowed us to gain access. That is not good. So let's see what we can do about this. We're going to close that, and we're going to go forward and see what we can do. And obviously what we can do is to install a web application firewall. Okay, and the idea is that we will be able to then prevent that attack taking place. So what are we going to do in this case? It's quite simple. We have a script that we need to download. So we'll download that first. So off it goes, and it's down really quickly. And then we're going to run the install script, which is basically open-appsec install with --prevent. Now, --prevent, they're claiming here, is used in this playground, but in real life, you'd want to have detect and learn mode on. So that's the mode that it would start with. It would not only be it'd be watching and detecting and then learning. Okay, that's what you do in a real environment. But this is our test environment, and we just want it to prevent. So we're going to press that, and as you can see, it goes through. Now it's told us also that we can just go through and press the defaults, but I want to focus on this a little bit just out of interest. So as you can see, it has found the ingress, and it's giving a choice of what we want to do. Now it's telling us to just perform the defaults, and the default is to duplicate an existing ingress and add open-appsec to it. Okay, so existing and new ingresses will run side by side. All right, so let's press that. Okay, and it wants me to enter an existing one, so I did. Okay, do it again. It's doing its magic. And it's coming through and telling us basically the rules now, the rule set, the policy which it will use. And as you can see, what we see, it's important here. The mode here will be prevent and learn. Okay, so it's going to prevent, but it's also going to be learning. And most importantly, what's going to be the response when it doesn't like something? Okay, in that case, it's going to show a 403 forbidden. Okay, so that's what we want. And it is offering us to save. Now it says you could change a rule, you can add a rule, so there's plenty of manual manipulation that could take place. I'm just going to save this as I suggested. And now it's telling us, well, how do you want to apply this to your setup? So you can create a YAML manifest or a Helm chart. I'm going to go with the default because it told us to. The manual YAML. That's one of those tough ones to say. YAML manifest. All right, so last but not least, it's telling us, do you want to receive a ton of emails? No, I don't. This is, I think, only in relation to important security updates, whatever. I mean, you could if you wanted to. I'm going to say no, ignore. And you want to apply this? Yes. So off we go. It's installing open-appsec through Helm, and it will apply the rules that we have just set it to. Now, we're doing this very basically. This is a much more complicated application, like most web application firewalls are. But this is just to prove what it's going to be able to do. Now, when it comes to security, I highly recommend that you don't take it all upon yourself. Complicated subject, and it's also a dynamic subject. It is not static. So getting back to the certifications I was talking about at the very beginning, there's a reason why the CKS is only 2 years valid, and the CKA and the CKD are 3 years. And it's because Linux Foundation figured that, well, security, it's too fast moving. Things change too quickly, so we're going to make the certification only valid for 2 years. Okay, we're done. Excellent. Let's check to see if it likes it. Now, you could have gone through and looked at all what's been installed here. If you really want to go deep, and if we had more time, we would. Well, we can look at the CRDs just for fun. Let's do that. Customer resource definitions, and there's a whole bunch that is put in there. You can see things like policies, practices, log triggers. So those CRDs is added. Let's check to make sure it's happy that we've properly installed the web application firewall, and it looks like we have. So that's really good to know. Now let's, it says get a cup of coffee. I think we'll skip that. This is relatively fast though. As you can see, I didn't have time for that. Okay, start. So here we are. We're back to where we were before. And essentially, what do we want to do? We want to log, or try to log, back into our application. But this time, we know that we have a web application firewall running. All right. So let's give that a try. Again, it's going to say, click here. It's going to click here. Oops, no, I clicked the wrong thing. I've gone click happy. I want to click here. Well, let's open this in another tab, and we should see our beloved web application, Acme audit with its report about $1 million, whatever. Okay, so now let's get our SQL injection technique. Okay, now important to remember. Oh, you can see it's already there. I remembered. And I'll type some gobbledygook. But before I press login, I want to underline the fact I have not touched the application. So the application on the back end is the same application with all of those multiple vulnerabilities that they were talking about. Okay, so nothing has changed in the back end. However, what has changed is this time when I log in, I should see this, and I'm very pleased that I did. Otherwise, this would have been a bit of a disaster. So what do we see? Very, very simple. Remember, we talked about the fact that there was a response, which I believe is also editable. You could have put whatever you wanted to. You could have said go away or something, or some mean message. But what we wanted was an HTTP error 403. You don't have authorization to view this page. Okay. So again, our application is the same application. It has the same vulnerabilities. Nothing has changed. But instead, we've put this firewall in front of the application, and it's protecting the application. This was done by injecting it in with the ingress, so they're running side by side, and you can no longer access the application. Okay, so very important to think about that for a while, because how many applications do you have in your environment right now, and you're exposing your APIs, and the only thing you're relying on is, in a speedy fashion, upgrading your applications, updating them. So this is extra protection. And I said before, it will also learn, okay? All right, so let's just press next here, see what else it says. Oh, this is also important. So remember we talked about the monitoring and logging and the extra capabilities that this gives us? Well, here's an example. It's actually telling us, okay, well, you know that there's been a detection and a prevention, right? It has not allowed us into our database this time. So let's see if it's actually recorded this somewhere. And it's giving us the ability to check that out. I think I made a mistake there. Let's try that again. Off we go. Nothing yet. I think you have to wait a bit. In fact, why don't we try again just to really annoy it? When in doubt, just try again. We're going to try to go in there again to catch this. So here we are. We're putting our thing again. And there we go. We'll get our response. And now let's try that command. And boom, look at that. Okay, wow, look at all this. Very verbose. And it's telling us what has happened. So there's all sorts of detailed information which a security expert would be able to decipher. Me, at a glance, I can certainly see some things. I can see the security action that was taken was prevent. Okay. And it's a login you see here. There's a post that took place, and that's what it was preventing. I believe you can even see what the issue was. It's going to tell you what it thinks it was. Yes, it is. Look at this. Incident type, SQL injection. So it's actually determined that that was a SQL injection, an attempt at least, and it's even got what was put in, the username, whatnot. Excellent. So here you have logs, which you can then present as evidence or whatnot, and save them. Keep in mind as well that you could also connect this all up, I'm assuming, to a security system, which can then decipher these logs and collect them. But that gives you that extra ability. Okay, so that's excellent. It's going to send us off to our next challenge. And I believe that now in this next challenge, this is a little bit long, which I don't think we'll have time to do today, but I want to just talk about it. So if you have a lot of applications and you have more than one cluster, which can be the case in production, it can be very hard for you to go individually through and look at logs and whatnot. So ideally, whatever WAF solution you're using, you want to have some kind of a management console where this can all be brought together, and open-appsec does have that, okay? So say here, they've got a management console, which way we could connect this to and shown, what has happened. Now, I believe I can get to that myself here. However, I am not going to actually connect it up because that would take, I've done it before. It takes quite a bit, not quite a bit of time, but too much for this. But this basically what it looks like. You go to open-appsec, and here is your central management, okay? And you can go into your either Docker profile, there's Linux embedded agent profile, so it's a agents embedded in a Linux system, or your Kubernetes profile. Just go in there here. I said I'm not going to connect it up because I don't have time during this presentation, but I'll show you what it looks like to connect it up. Again, very simple. It's giving you all the instructions. Here, you would download the tools package and you would connect your deployment, okay? And then there's a few more steps you'd have to take. Eventually, though, you'd be able to go and see in the monitoring tab your applications, notifications, and you get all events that are taking place in your environment, okay? So keep that in mind as well. You want to be able to organize this and manage it correctly, or I'd say efficiently. Efficiently is the better word. Okay, on that note, thank you very much. This was a brief overview and very much so an introduction, but I think that this gives you now some food for thought. You can go forward, go a bit deeper, go into those sources that I provided as well, read those articles, and then choose a WAF. It doesn't really matter which one, in the sense that if you're on AWS, use the native one there. For bare metal, open-appsec is a wonderful choice, but don't leave your applications exposed in Kubernetes, okay? Thank you very much, and I hope you enjoy 20 days or 90 days of DevOps. I went down to 20 days. Thank you very much.